So, Python is famous for being super easy to learn and use, right? But what happens when you throw massive amounts of data at it? I'm talking millions of data points. Well, it turns out Python has a secret weapon, and we're about to pull back the curtain on it.
Okay, let's start with a little thought experiment. Picture a list with 1 million numbers in it. Your job is simple: multiply every single one of those numbers by 2. How long do you think that would take in Python? A second? Half a second? Go ahead, take a guess.
All right, so on the screen, you see two ways to tackle this. On the left, that's the standard way you do it in Python, with a loop. And on the right, that's the NumPy way. Now, yeah, the NumPy code is obviously way cleaner, but that's not even the best part. The real shocker is how it performs. And here's the punchline. The standard Python list took over 24 milliseconds. The NumPy array? Just 706 microseconds. Now, wait a minute. A microsecond is 1,000 times faster than a millisecond. That means the NumPy version is about 34 times faster. It's not even close. It's the difference between a noticeable lag and an absolutely instant result. This magic is a library called NumPy.
NumPy, which is short for numerical Python, is basically the engine that powers almost all serious data science and machine learning in the Python world. It's the reason Python can go from a friendly scripting language to a high-performance computing powerhouse.
So, at its core, NumPy gives Python a brand new type of object, this powerful array that is built from the ground up for one thing, crunching numbers and doing it fast. On top of that, it comes with a whole suite of mathematical functions ready to go. So how in the world is it so fast? Well, there are a few secret ingredients. First, unlike a regular Python list, NumPy stores all its data together in one continuous chunk of memory, which makes it super quick to access. Second, the really heavy lifting isn't even done by Python. It's done by code written in C, a much faster language. And finally, and this is the big one, it performs operations on the entire array all at once. No more of those slow one-by-one for loops. The absolute heart and soul of NumPy is its special kind of array. The best way to think about it is like a regular spreadsheet grid, but on steroids. It's a container that's built for pure speed and power.
This container is called an ND array, which just stands for n-dimensional array. There are really only two key things you have to remember about it. One, it's ridiculously fast. And two, every single element inside it has to be the same data type. So they're all numbers or they're all strings. That little rule is a huge part of what makes it so efficient.
And you know what the best part is? Getting started is so easy. You don't need to learn some crazy new concept from scratch. It all begins with something you already know and use in Python, a simple list. Then, with just one simple command, you wrap that list in np.array, and bam, you've just transformed that regular pokey list into a super-powered ND array. That's it. You've now unlocked all that speed and functionality we've been talking about. Now, these arrays aren't just single lines of numbers. They can have multiple dimensions. For example, this is a two-dimensional array, and as you can see, it looks just like a table or a grid. We can even ask it about itself, like its shape, which tells us it has 2 rows and 4 columns, or its ndim, number of dimensions, which is 2. Okay, now we get to the real magic of NumPy. Once you have your data sitting inside one of these arrays, performing math on the entire dataset becomes incredibly, ridiculously easy and fast. This whole magic trick has a name. It's called vectorization. Now, that sounds like a fancy technical term, but the idea is dead simple. Instead of writing a loop to go through each number one by one, you just apply the operation to the entire array, the entire vector of data, all at once. And this is what it looks like in practice. It's so clean. If this were a regular Python list, you'd have to write a loop. With a NumPy array, you just write data times 10, as if you were just working with a single number. And boom, the result is instant. Every single element in that array got multiplied by 10. This is called an element-wise operation, and it is the absolute foundation of NumPy's power. Subtraction, addition, division, it all works this exact same simple way. But what good is a giant, fast dataset if you can't find the specific pieces you're looking for? Well, NumPy gives you these incredible tools for selecting and manipulating your data with pinpoint accuracy. Think of it like being a surgeon for your dataset. For the next few examples, let's just use this simple 3x3 grid of numbers. It's a nice, clean, two-dimensional array with 3 rows and 3 columns to play with. So how do we select just a specific chunk of this grid? We use something called slicing. The syntax might look a little strange at first, but it's incredibly powerful. Before the comma, :2 selects the rows. The colon means everything up to, so we get rows 0 and 1. After the comma, 1: selects the columns. This means from index 1 all the way to the end. And you can see exactly what that code did. It just carved out that precise piece of the data we asked for. This ability to slice and dice your data is absolutely essential for any kind of analysis. Simple slicing is great, but real-world questions are usually more complex. You don't want row 1. You want all the data where the name is Bob, or maybe where the value is greater than 90. How do we do that? This is where another NumPy's superpower comes in: Boolean filtering. You can compare an entire array to a value all at once. So when you ask which names equal Bob, it doesn't just give you the names back. Instead, it creates a brand new array of true and false values that acts like a mask or a filter. And for the final step, we just apply this Boolean filter to our scores array. NumPy automatically knows to only keep the rows where our filter is true. And just like that, we have all the scores for Bob. It's an unbelievably powerful and efficient way to filter your data. So we've covered a lot pretty quickly here, from creating arrays to doing math and filtering data at lightning speed. You might be wondering, okay, what's the big picture? Let's recap what this means. You can now handle huge data sets way faster than you could with basic Python. You can perform complex math with incredibly simple code. And you can select the exact data you need with surgical precision. Essentially, you've just unlocked the main entrance to the entire world of data analysis and data science in Python. This is where it gets really exciting. You now have the keys to a high-performance engine for data. Think about all the data that's all around you, in spreadsheets, on websites, in scientific research. With NumPy, you have the power to analyze all of it instantly. So the only question left is, what problem are you going to solve first?